So imagine transforming your business into living, breathing system where you have role, tasks, everything's organized in graph representation. Because before building any agentic system, you have to have an interactive business representation. And then we can find something that we can automate to the business. So first of all, my approach, which is ARA or Agentic Role Augmentation, which is about trying to find something that we can automate in the organization to make the process faster and to accelerate the processes in the business. So we can say that 70% of the average employee tasks can be emulated in agentic AI, and 30% is creative work that is hard to be emulated in agentic systems. And this is the purpose of agentic role augmentation. It's about finding the things or finding the workflows that we can automate in the business process. So it's about analyzing how people working in the organization and they map their roles and interactions into graph structure. And the reason why we map this into graph structure is graph representation is quite useful if you want to understand the nature of the job or the nature of the business processes, in which we have entity and we have relationship between two entities. So let's say, imagine now I'm a content creator and you are a viewer. So I'm an entity and you are an entity, and we have a relationship between us. So we can represent pretty much anything using graph representation. So the first step is to embed the graph or embed the business into graph to be able to visualize how the processes are working together. And this makes more sense because when we deal with the business owner, we take or we receive raw human input or raw text data, and we need to map all these data in the steps or in workflows to be implemented or to see something that we can automate. So the main input is the human raw language or the raw human input, which is the natural language. And we have to map this into graph representation to be able to, find the things that we can automate. And by converting the business processes into graph representation, we kind of check different roles, tasks, and people and different interactions between all these people within the organization. And as I mentioned, why we need to represent this in graph is humans describe their working stories not in diagrams. So literally we are taking the requests or we are taking the narrative or we are receiving the narrative in a natural language, and we gotta build or represent it in a structured way in which we can, brainstorm and visualize and do pretty much anything we need when it comes to agentic stacks. So these stories are unstructured. And the reason why I like to work with graph is it's a general way or a general concept of representing things in life. So as I told you, we can represent anything in life in graph representation because anything in life is entities and relationships. It's a general concept that makes the process of finding things that we can emulate or we can automate much easier. So by having the graph representation, we can understand the actual workflow. We can spot hidden, roles or overlaps and discover more complex logic that we can resolve in the future. And when it comes to graph representation, we have something called the triples extraction. And as I mentioned, we have node or the head or edge, and we have the relationship, which is R, and we have tail, which is the second node. So we need to map or we need to extract the three entities from text. So for that reason, we have triples. So we have the raw data and we need to extract triples from these raw data in order to map or represent it in a graph. And then we can use this graph for any kind of reasoning or visualization, understanding the business, and so many use cases that we can repurpose graph representation in. So when it comes to embedding or extracting triples, we have two main ways. The first one is automatic, and the second one is manual. And to be realistic, no one is using manual extraction for triples. It's more accurate, but it's a very exhaustive process. Imagine having a document about how business is operating, and this document is about 10 pages or 20 pages, and they need to extract entities and relationships. It's going to be quite exhaustive and doesn't make sense. But what makes more sense is automatic triples extraction. So now we have the raw text that we need to extract, and the raw text can be represented in article, PDFs, whatever, databases even. So to extract triples automatically from raw text, we have few alternatives, as you can see there. we have model called it OpenIE, which is Open Information Extraction. And this model is customized to extract triples from data. So it is custom and built for that purpose. But it takes more computations. It's a bit harder to use. And I prefer using the last option, which is LLM-based approach, in which we are applying some prompt tuning and asking the LLM to extract entities and relationships or triples from the raw text. And I prefer this option because it's easier and more straightforward. And in our case, we are going to use Gemini API key or Gemini 1.5 Flash because it's free and you can get the API fully free from Google AI Studio. So after extracting triples, we gotta move to the next step, which is about building the knowledge graph from triples. So now we have the head and relationship and the tail, the three main entities of any graph representation. Now we need to represent this in a graph using library like network KX or RDFlib. And for us, we're going to use the first option, and so many other things that we can leverage from having graph representation. So we can visualize or embed the graph into numeric data to be used for any kind of reasoning. And the graph is the best way to represent data when it comes to complex scenarios in which we need the agent to have strong and high level reasoning. So by having graph representation, you can transform it easily into a knowledge graph, and then you can leverage it to make the agent reason in a smarter way, because graphs are the best way to handle complex data in which you need the agent to extract data efficiently. Knowledge graph is the best way to represent complex data. And I strongly recommend you to read this post about knowledge graph and AI agents, because literally knowledge graph is a game changer when it comes to reasoning, because as you know, agents need to have this kind of knowledge. And by extension means that agents need to retrieve data in an efficient way in order to perform strong reasoning over these data. So once you have the graph, you can do anything you can imagine. You can embed it, you can visualize it, you can use it in knowledge graph and so many other things. And even for yourself, you can imagine and visualize how business is operating with just to have this kind of representation. And after representing the data in graph, then we can move to the step number 2, in which we can detect something that we can automate, or can detect any kind of workflows that we can emulate in AI agents. So this is the purpose. We need to find something or find opportunity in order to increase the business capacity and accelerate the processes. And I've talked about my approach in building scalable agentic systems in which we don't need to map any interactions or any inner interactions between the agents. We just can control pretty much everything with the help of orchestrator-based approach. So you can check the video that I've made about this topic, and I will link this video in the description below. So don't forget to check it after watching this video. So anyways, in this video, I was talking only about how to build and how to embed any business problem into graph representation. And now it's time to jump into the implementation to see how we can implement this in Python code. So as you can see, I just received it, how tutors are working in a university, and the business owners want to automate or find something that we can automate in order to increase the capacity, because the number of students is increasing and they don't want to hire more tutors. So they want to find something that they can automate, and then they can increase the number of students without any need to increase the number of tutors. So as you can see, this is the actual specs that I've got, 30 minutes ago. So these are the specs about how tutors are working in the university. And as you can see, it's just natural language and, it's just specs or narrative. She's just telling me how tutors are helping students, what the actions that tutors can take, and they have to map all these things into graph representation. And then I can brainstorm and I can use this graph for agent reasoning. I can use it for visualizing how business or how tutors are working in the university. I can use it for tens of use cases. And this is the reason why I'm encouraging you, if you are working in agentic or any agentic project, please go and map the business problem into graph representation, and you will make it once and you will use it for tens of times. So yeah, these are the specs. As you can see, it's a random text without any structure. And this is the normal case because you are dealing with non-technical people. They don't know about graphs or any kind of these technicalities. They just giving you documentation or narrative or a story how their business is working, and you have to map this in a way that helps you to implement and find something that you can automate, because this is the purpose of agentic AI. The purpose of agentic AI is to optimize business processes in order to increase the capacity, reduce the human factor, or do anything that can be meaningful to the business. So as you can see, it's like, I think it's about 10 messages with the specs, and I just, extracted or copied all these messages and represented in this txt or text file. So first of all, we have this main file that map or use Gemini LLM to map this random raw text into graph representation. The logic is quite simple. We just, importing the libraries that we are going to need, like network KX for building graph, and, Google generative AI to be able to communicate with the LLM from Gemini. And as I mentioned, you have to get your API key, which is totally free from Google AI Studio, and then you will store it in .env file, and you will read it in this variable, which is Gemini API key. And then we are just configuring the model that we are going to use, which is 1.5 Flash, and we are reading the text data, which is raw data.txt. And this is the prompt that we will send to the Gemini LLM in order to extract the features that we want to extract from the raw text. So the prompt is saying simply extract knowledge graph triples from the following text in the format subject, predict, and object. So you can name it in a different way, like hit, relation, hit, relationship, and tail. So it doesn't matter what's the naming, but we are saying focus especially on workflow relationships, processes, and automation opportunities, because we need to find something that we can automate. So this is the purpose of embedding the business problem into graph representation. So as you can see, this is the prompt that we're going to send to the Gemini LLM, and we are just attaching this text with the text data, and we are receiving the model response and response variable. So the logic is quite straightforward, and I'll provide the link of this script in the description below. And yeah, we are just getting the triples from the Gemini LLM, and then we are just mapping these triples into graph representation to build the graph in a way that we can visualize. And then you can embed this graph in a way that you can retrieve data from for agent reasoning or any purpose as you want. So I will just run this script to generate the graph representation based on the raw data that I stored it in this file. So let's run Gemini KG extractor. So let's open the terminal. Yes, there we go. Successfully extracted 40 triples from the text. So we can open this from the root directory to visualize how the graph is constructed. So as we can see, this is the output. We can zoom in. It's very interactive, it's amazing. So as you can see, this is the mapping of the raw text. So we have initial meeting, we have prep-year discussion, support and the questions, academic questions, and end of year questions. It's kind of, saying that the end year questions is a part of ongoing support. So we have this node, which is ongoing support, connected with other nodes, which is prep year, initial meeting, support questions, and so many other things. So it's a good way to express or visualize how this business is operating. So we can find something that we can automate, like we can build the agent that can assist the reviews or assessment reviews. So we can just build an agent or multi-agent systems that can done this task. So we can just delete this node from the system, and there we go. And we are just simplifying, so this is the purpose of agentic AI. And I think this way of expressing or this way of representing data is very good to know how business is operating in a way that you can visualize and use it as retriever for any kind of agent reasoning. So yeah, that's for today. If you found this video helpful, don't forget to subscribe and see you in the next video.